Hi folks, we're going to take a look at page 2 from Unit 3, Lesson 2. So we have this question which gives us a graph of the velocity function. So very important here is that this is the velocity, not the position of a particle moving a straight line with respect to time. All right, so here it says for what time or times is the particle moving in a negative direction. All right, so this is where we remember what we determined. We said that if you're moving in a negative direction, so let's say we've got this being our straight line, this being our origin, moving in a negative direction, okay, if we consider that to be positive, this to be negative, means that the rate of change of the position needs to be negative. In other words, the velocity needs to be negative. So anywhere on this graph where the velocity, which is the function that's given, is negative, will satisfy the condition given here. So let's see where it's negative here. Well, it starts at about 3.3. Okay, now at 3.3 it's equal to 0, so it's neither positive or negative. So that's why I'm using open intervals here. So from 3.3 to looks like it's 6, we have negative values of the velocity, and then from 6 to 7, which is where our experiment ends. Okay, I'm not including 6 because at that moment it's momentarily stopped, so it's neither moving in a positive nor negative direction. So here we have t is in these intervals here where t is in seconds. All right. So we just used a property that we determined which had that moving in a negative direction was equivalent to the velocity having a negative value, which encompasses all of these here. All right, so let's take a look at B. It says, what is the particle's highest speed? And justify. So here actually we didn't justify. We should say since v of t is negative on these intervals. All right, so here the highest speed. Now remember that the speed is not the same as the velocity. Velocity incorporates a direction. The speed is just given by the absolute value of the velocity. So just how fast you're going as opposed to how fast and in what direction. So while I look here and I see the highest velocity that's attained is 4, what I want to be looking at is the absolute value of v of t. I don't actually have to draw it, but imagine taking the absolute value of this function. All these negative values would suddenly become positive, and so I see that the highest absolute value occurs at 5, where the function takes on a value of negative 5. If I consider its absolute value, we see that it's 5. Okay, so the highest speed is going to be 5 meters per second. Okay, and why? Because that's where the absolute value is maximized. Okay, since largest value of the absolute value of the velocity. All right, so let's go to the next one here. It says, for what time or times is the particle stopped? Okay, so you're stopped if your velocity is 0, and we see that that happens at 2 times. Okay, it happens at t equals 3.3 seconds. Okay, and it also happens at t equals 6 seconds, and this is because v at t, the velocity is equal to 0 at those points. So there's our justification. All right, and let's move to the next question. It says, for what time or times is the particle speeding up and slowing down, and justify? Okay, now there's 2 ways we can look at this. We can look at it more directly on the graph. So we can see that in this first section from about 0 to 1.5, the speeds, so notice here I'm not so much interested in velocity, but the speeds are getting larger, so speeding up. Here the speeds are getting smaller, so slowing down. Here the speeds, remember the absolute value of the velocity, are getting larger, so speeding up. Here the speeds are getting smaller, slowing down, speeds getting larger, speeding up. Okay, but I'm going to take a different approach because it'll be easier to, I think, explain or give a justification. And it's also a justification that will work when I don't necessarily have the graph. And that's this idea that an object is speeding up if the velocity and the acceleration have the same sign, and it's slowing down if they have opposite signs. And we're going to see that we get to the exact same conclusion. If I look between 0 and 1.5, I see that the velocity is positive, and if I look at the slopes of the tangents, happens to be a straight line, so it's nice and easy. I see the acceleration, which is a derivative of the velocity, is also positive. In this area here, The velocity is still positive, but the acceleration is negative. Opposite signs, hence slowing down. And then similar things happen for the other scenarios. All right, so I'll put here speeding up. Okay, so we have speeding up here from 0 to 1.5. Okay, and why? Since the velocity is greater than 0 and the acceleration is also greater than 0. Okay, there's all the justification we need. Now in this section here, we're not going to include that at all because the velocity remains the same, meaning it's neither speeding up nor slowing down. So our next section will be from 2 to about 3.3. Okay, but that's going to go in our slowing down category. Okay, so here we have under slowing down, we've got 2 to 3.3. And why is it slowing down? Because the velocity is positive, but the acceleration is negative. Okay, signs are opposite. Okay, in this section here, from 3.3 to 5, we see that the velocity is negative, and so is the acceleration, because the slope is negative. Okay, so that'll go under speeding up. So 3.3 to, what do we have? 5. Okay, and why is that? Because both the velocity and the acceleration are negative. Then we go from 5 to 6. We see that the velocity is still negative, but the acceleration here is going to be positive slope. Okay, so from 5 to 6, okay, it's slowing down because the velocity is negative, but the acceleration is positive, opposite signs. And then lastly, from 6 to 7, we see that the velocity is still negative, but the acceleration, because the slope is negative, is also negative. So from 6 to 7, okay, it's speeding up since both the velocity and the acceleration are negative. And this is how we can justify our answers. All right. So let's move on to number 5. Now, before we move on to number 5, I'm not quite sure that we talked about this. So we talked about how we could use the signs of the velocity and acceleration to determine when an object is speeding up or slowing down. Another thing we can look at, and again, if you've looked at the notes, is talking about moving away and toward the origin point. So let's see how that works. So there's two ways that I could move away from the origin. I could be moving away in this direction, but I could also be moving away from the origin in that direction. All right, so let's see what happens. Okay, not sure if you saw that little stoppage. Hopefully you didn't. Anyways, so if I take a look here, what's happening when I'm moving away on this side? Well, I see that the position is positive. Okay, and because I'm moving towards the right, the acceleration is also, the velocity is also positive. Whereas if I'm moving away on this side, I have my position is negative, okay, but because I'm moving towards the left, my velocity is also negative. So we're starting to see that when the position and velocities have the same signs, you're moving away from the origin. Whereas, and let's look at moving towards, if I'm moving toward the origin on this side, I see that my position is positive, but I'm moving towards the left, so my velocity is negative. Okay, and similarly, if I'm moving towards the origin here, okay, I see that my position is negative, but my velocity, because I'm moving towards the right, is positive. So we see that same sign for position and velocity, moving away from the origin. Opposite signs for position and velocity, moving towards the origin. So this is what I'm going to use now to help solve question number 5. And we notice here that in question number 5, we're not given a graph. Everything is done using the equation, which is mostly how we're going to be doing this. Now, by the way, I had S. I guess I used to use S for position, but I hear in physics you're using D. So that's why we'll change this to D here. All right. So it asks us to determine when the vehicle is moving toward and away from the origin. So now, as we've seen, that's going to involve working with position and velocity. And then the time intervals during which the vehicle is speeding up and slowing down. That's going to be doing what we did up here, is using velocity and acceleration. So I'm going to show you a trick to doing this. And the first thing is to determine all the functions, so position, velocity, and acceleration, and also determine their x-intercepts. In other words, where they can change sign. So we have the position function. So let's start factoring this out. So factor out a t, and I'm left with t squared minus 2t plus 1. And so that factors to t minus 1 squared. Okay, so we can use these zeros to help us determine the sign of the function. Then we'll go to the velocity, but of course the velocity is just the derivative of the position function. All right, so let's take the derivative. We have 3t squared minus 4t plus 1, and luckily this factors out nicely. So this ends up being 3t minus 1 and t minus 1. Okay, so negative 3 minus 1, negative 4. And now let's find the acceleration, which is just the derivative of the velocity function. And so let's take the derivative from this one here. We end up with 6t minus 4. All right, and if we want to factor this out, factor out a 2. And what do we have? We have 3t minus 2. All right. Now, in order to determine the answers to these questions, it's all about comparing the signs. So what I'm going to do is I'm going to create 3 number lines, but one over the other, so I can easily compare. Okay, so first thing is to realize I'm not interested in anything below 0, so I'm going to start here at 0. And let's take a look at my x-intercepts. So I've got 0, 1, here 1 and a third, 2/3. So I'm going to put 1 all the way here. So I leave myself lots of room. Okay. So the only intercepts I have to worry about here are 0 and 1. So let's take a look at how this behaves. It's a cubic, and I have a positive leading coefficient. So I'm starting at negative infinity. I'm coming through 0, so it's positive. But then at 1, I have a 0 of order 2, so it's just going to bounce off. So in other words, the position will be positive on both sides of 1. Okay, so this is going to be my position function. Next, I'm going to draw my velocity function. Now, where are the zeros here? At 1 and at 1/3. So here I've got a 0, and at 1/3 I've got a 0. And let's see what happens. Well, this is just a quadratic with a positive leading coefficient. So it goes from positive to negative to positive. So positive to negative to positive. Okay, and lastly, I'll take my acceleration function. All right, and the only place it can change sign is at 2/3. All right, and this is just a line with a positive slope, so it's increasing. So it's going from negative to positive. And now what I can do is, if I'm trying to determine when it's moving away and moving toward, so moving away and moving toward, okay, I just have to look at these 2 lines. And I'm just going to draw little dotted lines here to help me out. So I see that from 0 to 1/3, both position and velocity are positive. And as we saw above, when they have the same sign, I'm moving away. So from 0 to 1/3, sorry about that, I'm moving away. Okay, but from 1/3 to 1, they have opposite signs. So I'm moving toward. So from 1/3 to 1, I'm moving toward the origin. And then greater than 1, I see that they have the same signs, so I'm moving away. So 1 to positive infinity, I'm moving away. Now let's look at speeding up and slowing down. Okay, now I'm focusing in on these 2 lines. Okay, so I'll bring this 1/3 down, this 2/3 up. All right, and let's see what's happening here. All right, so from 0 to 1/3, well, acceleration is negative, velocity is positive. So opposite, meaning I'm slowing down. So from 0 to 1/3, I'm slowing down. Then from 1/3 to 2/3, both negative, so I'm speeding up. All right. And then here, from 2/3 to 1, positive and negative. So again, I'm slowing down. So from 2/3 to 1, opposite signs, so I'm slowing down. And then from 1 to infinity, both of them are positive, so I'm speeding up. All right, and there you have it. So just to recap, notice how answering almost all of these questions involved looking at the sign of either the position, the velocity, or the acceleration function. Here I did that all by observing the graph, whereas here I used our methods for determining the sign of a function by determining x-intercepts and creating our number lines. Okay, that's it.